all for having me. As she said, my name is Jeff Brown. I work for Object Computing based in St. Louis, Missouri. OCI is the new home of the Grails framework. We're really excited about getting under the OCI umbrella. We just made that announcement publicly a few weeks ago. So we're really excited about that. It's great time for the Grails framework. We got lots of cool stuff coming. So pay attention to OCIweb.com and at Object Computing on Twitter in the coming months. We're going to have lots of interesting things to say. But I want to get right into the technical discussion at hand here. So this session is titled GORM Inside and Out. And what the session is really about, or what it's typically about, is I talk about GORM from the inside and from the outside. So from the outside is from the application developer's perspective, right? So you're building a Grails application and you're writing GORM code and you're taking advantage of where queries and dynamic finders and taking advantage of all that GORM has to offer. That's you looking at GORM from the outside. And then the inside part of this is digging into some of the details, the dirty details, not dirty details, but the complexities of how a lot of this works. GORM provides a lot of really powerful kind of magic stuff. And kind of take a look behind the curtains and talk about how a lot of that works. And what I've found throughout the day, so I've been speaking all day about different Groovy and Grails topics, is there are a lot of folks here who have expressed in hallway conversations and in questions during sessions. There are a lot of folks who would like to sort of back it off a little bit and talk about maybe a little bit less complicated details around Groovy and Grails. And I'm going to do that during this talk. I'm going to back off and not get into as hardcore of details as I typically do in this talk. If that's really what you came for, I'm happy to talk to you after the session about that. Maybe we'll get into a little bit of that during the session. But if you're already kind of a GORM guru and know all the ins and outs of how to use GORM, and you're really just here to learn about some of the internals, please see me after the talk, and I'll be happy to talk with you about that all you like. I love to talk about this stuff. But I am going to sort of back off the complexity relative to what might have been in the abstract. So I hope that works for everyone here. As we're moving along, if you have any questions at all, please speak up. The more interactive you make this, the more fun it'll be, the more interesting it'll be for everyone involved. So please don't hesitate to speak up, and let me know if you've got questions. So I want to talk just a little bit about the problem with ORM in general. I don't want to spend a whole lot of time here, but just talk about it briefly and then jump right into the powerful details of GORM. So there are ORM solutions out there for Java, right? Hibernate is the most probably the most widely used, most well-known ORM tool for Java. ORM, of course, is object-relational mapping, right? So you want to build a system in an object-oriented programming language like Groovy or Java. And you want to store your data in a relational database like Oracle or PostgreSQL. So you've got this mismatch between your object model and your persistence model. Your persistence model is a bunch of tables and so forth, and your object model is not that, right? It's an object graph. And sometimes the objects in that graph map one-to-one to tables in your database, and sometimes they don't. But it turns out there's a lot of complexity in making all that work, and that's why so first I'll state ORM is hard. And the reason it's hard is there's lots of complexity in mapping kind of the impedance mismatch between your object model and your persistence model. So there are ORM solutions out there to help solve that problem. Those solutions do solve that problem. Hibernate is probably the most popular, most widely used solution for Java anyway. Hibernate's really powerful, really flexible. It will allow you to map just about any object graph you like to just about any relational database, right? If there's a relational database out there that has a JDBC driver, then almost certainly you can get from point A to point B using Hibernate. Whatever your object model looks like, you'll be able to map it to whatever your persistence model looks like for the most part. So Hibernate's really flexible, really powerful with respect to that. It can also be fairly tedious and complicated. In the early versions of Hibernate, you had to write these XML configuration files, and then later things improved in that space. So you had to write maybe less configuration stuff than you did in earlier versions of Hibernate. But one of the costs associated with using Hibernate is that configuration step, right? So you write your Java domain classes, and one way or the other, you have to tell Hibernate about some of the details. You have to tell Hibernate which of your classes that you want to map to the relational database. So what you don't want Hibernate to do is just grab every class in the JVM and map it to your database. That's crazy talk, right? You don't want to do that. There are specific classes in your application that you want mapped to the database, and you have to tell Hibernate about that. One way to tell Hibernate about that is by authoring these Hibernate CFG XML files, right? These XML files that describe which classes you want mapped to the database and how you want them mapped. And that how you want them mapped can be things like expressing table names and column names and primary keys and joins and all that stuff. So you're expressing a lot of that stuff in configuration one way or the other. That configuration might be XML files, it might be annotations, but somehow you've got to tell Hibernate about your domain model and give it enough information that it can do what it is that you need it to do. GORM, the ORM solution in Grails, simplifies a lot of that by taking advantage of this really powerful idea that shows up in lots of places in the Grails framework, not just in GORM. But the idea of convention over configuration shows up all over the place. So in Grails, there are lots of cases of this where you follow a certain convention, and doing that allows you to forego what otherwise would have been potentially a bunch of configuration work. You're following a convention instead of writing configuration stuff. So a simple way that manifests in Grails is in every Grails application, at the top of your project, there's a folder called Grails-app. And below Grails-app is a folder called Domain. And that is where all of your domain classes go. So if you create a class, put a source file under Grails app/domain. That class is automatically configured as an entity in Hibernate, right? So in a typical Java application, you write your entity class and then you tell Hibernate about it. You either use annotations or config files or whatever, but you've got to tell Hibernate about those classes. That also has to happen inside of a Grails app, but you don't have to do that second step, and that is you don't have to tell Hibernate which of your classes are domain classes, or which of your classes are persistent entities. What you do is you declare, if you put source files under Grails app/domain, Grails will recognize that and will pick up all of those classes and then go configure them in Hibernate on your behalf, right? So you get to skip at least one step, right? You don't have to tell Hibernate about which of your entities which of your classes you want mapped to the database. We're automatically going to map all of the classes that are under Grails app/domain. If there's a class under Grails app/domain that you don't want mapped to the database, then already something's gone wrong. Don't put it there, right? That's the whole reason you've put the classes under Grails app/domain, is you want them mapped to the database. So the first convention is just that. All of the classes defined under Grails app/domain are configured as persistent entities. And then as those entities are configured, there are lots more conventions that will come into play. So for example, if your class is called Bookmark, if your domain class is called Bookmark, by default, that class will be mapped to a table in your database called Bookmark, because that's a reasonable default, right? So that's another example of convention over configuration. The convention is your class name corresponds to a table name in the database. And if that's not what you want, there's a way to deal with that, and we'll look at examples of that later. But that's a sensible default, right? Convention over configuration and sensible defaults are where a lot of really cool productivity gains come from inside of the framework. All right, so you've got a bookmark domain class. You've got a bookmark class in your domain directory. So that class is automatically mapped to the database, and it's mapped to a table called Bookmark. If the Bookmark class has properties like title and URL, there'll be, again, by default, there'll be columns in your table called title and URL. So when you create a bookmark and persist it to the database, Hibernate has a place to put the values for those properties, right? If you have a bookmark that has a title and a URL and you persist it, both of those pieces of information have to go someplace, right? And they're going to go into a particular column in the bookmark table, and the column names by default will match your property names. Again, that's a sensible default, and there's a way to deviate from that we'll see later, but that's a sensible default. If a property in your domain class is a reference to another domain class, so here we've got in the bookmark class, we have a property called creator that is of type user. So user is another domain class. So inside the bookmark table, which is what you see at the top right there, there's a column called creator ID, and that's a foreign key that points to the user table, which is where your user objects are stored. So users have a name, and the has many business we'll talk about in just a minute. But we've got this graph of objects, right? We've got a bookmark, and a bookmark has a user, and a user has many bookmarks. We've got a one-to-many kind of relationship there. With writing the code exactly as you see there on the left, you can drop that into a Grails application and start it up, and don't do anything at all with your persistence. So you don't have to write any database code. Don't do anything else related to persistence other than define those classes as you see there, and a bunch of conventions come into play that allow the framework to map that graph of objects to the persistence engine. So far I've been speaking in relational database terms because that's the most common thing that folks want to do. But none of this is bound to working with a relational database. You can use MongoDB and other data stores, and I want to talk about that a little bit later. But for now, let's just think about things in terms of relational databases. But it turns out, I'll just sort of do a little bit of hand waving over this right now. The code that you see there would look exactly like that if we're using Oracle, or if we're using MySQL, or if we're using MongoDB, or if we're using some in-memory map-based data store. This is one of the great benefits that GORM has to offer, is it's decoupling you from those persistence details. So all the examples we're looking at so far talk about things in terms of relational databases. Most folks building Grails apps are taking advantage of just that. But all this would look exactly the same if you were using some kind of key store, document store database that GORM supports. Originally, GORM was built on top of Hibernate because most folks want to store their data in a relational database, and Hibernate is really the most powerful, most flexible ORM tool out there. So we built GORM initially on top of Hibernate, and later we got to a point where, well, pretty early on in the process, or early on in Grails life, one of the single most highly voted feature requests in our JIRA was JPA support. People didn't want to use Hibernate. They wanted to use JPA directly. So we had to decouple the GORM from Hibernate. So we did that, right? So now you've got GORM is this layer on top, and then there were adapters that allowed GORM to work with Hibernate. And also, instead of that, you could plug in adapters that allowed GORM to work with JPA. And then later on in Grails life, that got extended even further. So both of those are really ORM tools. They're tools for Hibernate and JPA, or ways to map a graph of objects to a relational database. Later on in Grails evolution, so-called NoSQL databases started to emerge and become more and more popular, and people wanted to use NoSQL databases. So we separated GORM even further, right? So GORM now was not only not bound to Hibernate, it wasn't even bound to relational databases. Now you can use GORM to talk to just about any kind of data store, including MongoDB and Cassandra and others. But initially, GORM was built on top of Hibernate because of the reasons I cited before. Hibernate was the most popular ORM tool. Most folks want to store their data in a relational database, so all of that made perfect sense. So we were able to take advantage of all the great stuff that Hibernate had to offer without imposing a lot of the cost and burden that Hibernate usually brings along, and that's the configuration stuff. And the way that GORM gets rid of most of that configuration stuff is convention over configuration, right? The conventions are imposed all over the place to really minimize the amount of configuration work that you have to do in order to take advantage of a complex and powerful ORM tool like Hibernate. All right, so I want to just drill into some specific details of some capabilities provided by GORM. So we see in this bookmark and user model, in the bookmark class, we see this static belongs to equals user. And in the user class, we see static has many equals, and then there's some stuff there, bookmarks : bookmark. Both of those are special property names. Belongs to and has many, those are special property names. Those names mean something to GORM in particular. And I want to talk a little bit about that. So inside of a domain class, if you declare a static property called has many, and assign a value to that property that is a map. And that's what we see at the top here. Static has many equals map. The first thing that we see in the map is the lowercase c comments, right? That's a key in the map, colon, and then a value. And the value associated with that key in this case is the comment class. So comments is the key, and the comment class is the value. What GORM is going to do with that is it's going to add a property to this class whose name is comments. And there's no magic pluralization stuff going on here. Comments is whatever you've typed into the source code there, before the colon inside the map. So GORM is going to add a property called comments to your domain class, and it's going to be a set, a java.util.set, and it will be a set that contains comment objects. So that back to that map, the value that's associated with comments is the comment class. That tells GORM what types of entities are going to be stored in this collection. So you haven't declared a comments property. You've declared has many equals comments colon comment, and GORM will run with that and add a comments property to your class. The property will be a java.util.set, and it will be constrained to be a set of comment objects. So now if you have a bookmark, you can refer to the comments property, and that will be a set that includes potentially lots of comment objects. So the code at the bottom there is, so bookmark must be a reference that points to a bookmark, and this is iterating over all of the comments in that bookmark and doing something, printing out their text, it looks like. All right? So is this all making sense? It's good stuff. Right, so you might say, well, why do I want to have to define has many equals comments colon comment? Why don't I just declare a set of comment, right? And if what I just described is all that happened, is all that was associated with has many, then has many wouldn't really be justifiable. We'd get rid of that, and there'd be no justification for having this feature. But it turns out a number of other interesting things happen as a result of having that has many there, and we're going to tease some of those out as we move along. So what I just described is just one of the things that happens as a result of defining that has many property. When a class declares a belongs to property, like we see here, a comment belongs to a bookmark. Inside the comment class, we've got static belongs to equals bookmark. What you're expressing there is that every comment has an owner that is a bookmark. And one of the consequences of expressing the relationship in that way is that if a bookmark has many comments, like we've seen, and the comment belongs to a bookmark, one of the things that happens when you delete a bookmark is all of its comments will automatically be deleted. You'll get cascading deletes kind of for free and by default. You don't have to do anything to make that happen other than express that that's what you want to happen. So static belongs to equals bookmark is your way of expressing that this thing belongs to its parent. And one of the things it means for a thing to belong to its parent is if the parent is deleted, the child should also be deleted. So in this case, again, if I delete a bookmark, all of its comments will automatically be deleted. And that's not a bug or a problem. If that's not the behavior you want, then don't express the belongs to there, right? You can leave the belongs to out and leave everything else the same. So now a bookmark still has many comments. But if I delete a bookmark, then its comments are just left out there, right? The belongs to says, I belong to my parent. When the parent is deleted, delete me and all my sibling, right? All the other comments that belong to this bookmark. So I said before that when you declare a has many, what happens is GORM will add a property to this domain class whose name is the key in the map. So in this case, we've got in the bookmark class over here on the left, a property called comments will be added to the bookmark class, and it will be a set of comment objects. If you want to take advantage of everything that has many has to offer, but you don't want to store them in a set, you want to store them in a list or a map, for example, the way to do that is still express the has many, just like you did before, but explicitly declare the comments property, which is what you see in the example up here. It says list space comments. You could also put set space comments, but that wouldn't buy you any. If you want it to be a set, then just leave it out altogether. The has many will add the set for you. The reason you want to explicitly declare the comments property is that's a way for you to express what type of collection you want to store the comments in. By default, the collection will be a set, and you've got 4 options. You've got set, sorted set, list, and map. Those are the 4 collection types you can use: set, sorted set, list, and map. If you want it to be a set, that's what you get by default. And if you want it to be a list, a sorted set, or a map, then you have to explicitly declare the property like you see on the left here and give it a static type of list, sorted set, or map. Does that all make sense? The key in the map in this case is comments, right? Right here, this is the key in the map. Yeah. A string, right? So if you're using a map, so for lists, sorted sets, and sets, the question doesn't apply, right? It's just a collection of comments. If you're using a map, the keys in the map have to be some type, and the keys have to be strings. That's you're limited to that. That's what GORM supports, is the keys have to be strings. So you don't express that any place because that's the only option, right? They can't be anything other than a string. Good. GORM supports components, right? So I can express that a bookmark has a note, right? In the bookmark class, we've got a property called DESC, which is short for description. And DESC is of type note. So normally what would happen is you'd have a bookmark table and you'd have a note table. And in the bookmark table, you'd have columns for all of the properties that are explicitly declared in the bookmark. In the note table, you'd have columns for all the properties that are explicitly declared in the note class. And then also in the bookmark class, you'd have a DESC underscore ID column, a foreign key column that points to a row in the note table. That's what happens normally. What components mean in this context here is in the bookmark class, I've expressed static embedded equals DESC. And that's a list of strings. In this case, there's only one string in the list, DESC, but there could be others. And what it means for something to be embedded is you're telling the ORM tool, you're telling GORM, that I don't want a foreign key from the bookmark table to the note table. I want all of the note attributes to be stored right in the bookmark table. Right? So there won't be a foreign key relationship. So in the bookmark table, I would have columns for all of these properties right here, right, that are ellipsed out here. So whatever properties are in the bookmark class would have corresponding columns in the bookmark table. And in addition to that, there'll be columns for all of these properties, text and last modified in the note class. So when I create a bookmark and I create a note and I associate the two by assigning a reference to the note to this DESC property in the bookmark class. So I've got these two objects on the heap and one refers to the other. When I persist the bookmark, the ORM tool knows to put everything in the bookmark table. Right? There's no foreign key, nothing goes in the note table. All the note attributes are stored in the bookmark table. Right? That's what the embedded business here is about. And that's one of the ways that you get to deviate, you get to manage differences between your persistence model and your object model. It could be the case that you really do want these things all stored in one table in your database. There are a number of reasons you might want to do that. Retrieving bookmarks and their note is going to be more efficient because there's no joins, right? All the information's in one row in one table. Another reason you might want all this stuff in one table is you're dealing with a legacy database and you don't get to decide where things go. The tables already exist with all these columns in it. But in your application, it makes sense to have a bookmark class and a note class, right? These are two different things from your application's perspective. So this is an example of your object model looking like whatever makes sense for your object model to look like, and your persistence model can look like whatever makes sense there, and you don't have to compromise one to satisfy the other. Right? We don't have to compromise our persistence model because we want our object model a certain way, and we don't have to compromise our object model because we want our persistence model to be a certain way. You can do what makes the most sense on both of those sides of the fence, and the ORM tool helps you bridge the differences between those. Yeah? It can, right? So the question is, can the note class still be associated with a note table and used maybe in some other context other than bookmarks? So the way this is written right now, if I create a note and a bookmark, and I relate the two by initializing this DESC property in the bookmark, and then I persist the bookmark, all that information gets put in the bookmark table. Nothing gets put in the note table. And then totally separate from that, if I've got some other part of the application that creates a note and persists that, without involving the bookmark class, now this embedded business doesn't come into play. I'm just putting notes in the note table, and that works how you would expect it to work. Yeah, that's a good question. So we'll look at a couple of examples of kind of deviating from the default conventions, right? So by default, if you have a class called person, that person will be persisted in a table called person. But if you want the table to be called people, one thing you could do is you could rename your domain class to be called people. That's a bad idea, right? So you want your person class to be called person, right? It represents one person. But it also makes sense for the table to be called people because you're not storing a person there, right? It's people. So if you want to deviate from the convention is the class name matches the table name. If you want to deviate from that, there's a simple way to do that, right? So in your domain class, you can declare this mapping block, which is what you see here, static mapping equals closure. And then inside of that closure is code that's really a DSL. It's a domain-specific language. And the domain is ORM, right? You're describing how you want this class mapped to the relational database. So Tablespace people, that tells GORM that when we send queries to the database to retrieve person objects, or when we persist person objects, go to a table named people. Don't go to a table named person. Go to a table named people. All of your domain classes by default have a property added to them called ID and another property added to them called version. And the version property is used for optimistic locking. So when you retrieve an object and make some changes to it, before you go persist that object back to the database, you can make sure the version in the database is the same version that you retrieved because you've got this version number. So there's a version number added to all of your domain classes for optimistic locking purposes. If you want to turn that off, there are reasons you might want to turn that off, like maybe you're dealing with a legacy database that doesn't have a column for that, or you just don't want to take advantage of optimistic locking for various reasons. If you want to turn off that version property, there's a way to do that, right? Version space false. You can do things like configure the second level cache and configure the ID generator. So the ID generator high-low business there is, that's terminology that's probably familiar to you if you've done much with Hibernate. There are different generator strategies for generating IDs, right? There's a sequence generator, there's 1, 2, 3, 4, 5. There's a high-low generator. There are a number of generators supported by Hibernate for generating your IDs. One of them is called assigned. So if instead of ID generator high-low, if instead of that we had ID generator assigned, what that means is it's up to you to come up with your own IDs. You have to assign a value to the ID property before you persist the thing. And there are reasons to do that, but most people don't want to do that. The default ID generator is usually what you want. I think the default is native, which means Hibernate will use a mechanism that makes sense for that particular data store. So maybe MySQL's there's a generator that makes more sense for MySQL but would make less sense in PostgreSQL. So if you said ID generator :native, Hibernate's going to use a strategy that makes sense for Postgres and maybe a different strategy for MySQL. I don't happen to know what the defaults for those two are. They might be the same, but that's what you get to configure how your IDs are generated by Hibernate. By default, all of your properties are mapped to column names that don't necessarily match your property names, but are derived from your property names. So for example, in the person class, we've got a property called first name, camel case, first uppercase N name. So by default, that's going to be mapped to a column called first_name. And maybe that's not what you want. Maybe the column in the database is called fname, right, for first name. You could rename this property to be fname, and now you'd be in business, but that's goofy, right? You don't want to do that. You really want the property to be called first name. For some reason, you want the column in the database to be called fname. Maybe it's a legacy database. You get to configure that, right? So first name, column, : string. That string represents the column name for that property. Almost always, the default is what you want here, right? The property name, the column name that would be generated from the property name is almost always what you want. It's not very common for folks to have to configure individual column names, but it's important that that feature is there because there are times when you're going to want to do that. You're mapping to a legacy database. You don't get to control the column name, so you don't want to be stuck there, right? You get to configure things when you need to. So this is an example of what configuration looks like in a GORM application. All of this is only necessary when you want to deviate from the defaults, right? Sensible defaults are a big part of where a lot of the productivity gains in the framework come from. We impose sensible defaults to minimize the amount of configuration work you've got to do. You've only got to do configuration work when you want to deviate from those defaults, and that configuration work is almost always in the form of Groovy code, not an XML file or some other file. It's almost always in Groovy code. We've got DSLs all over the framework for managing this sort of thing. I said before that when you declare a has-many relationship in a domain class, a number of things happen. One, you get that collection added to the domain class that we talked about. Another thing that happens is GORM will automatically add some methods to your domain class for managing those relationships. So in the bookmark class, if we had static has-many equals bookmarks, or I'm sorry, static has-many equals comments colon comment, right? In the bookmark class, we've got has-many equals comments colon comment. So a bookmark has many comments. GORM will automatically add methods to the bookmark class with names like add to comments. It's add to and then whatever the key in that map was. So the key in our map was comments. So there's a method called add to comments added to the bookmark class. That's a reasonable thing that you'll want to take advantage of. There are actually overloaded versions of that method added. There's an add to comments method that accepts a comment as an argument. So you've already got a comment object, and you've got a bookmark object, and you want to add the comment to the bookmark. So you call bookmark.addToComments and pass the comment as an argument. The syntax you see here is pointing out that we're invoking an add to comments method that doesn't accept a comment as an argument. It accepts a map as an argument. So in this case, I don't already have a comment that I want to associate with the bookmark. I want to create a comment and associate that with the bookmark. So I could write the code that says def c equals new comment, text colon great, left by Joe. So I've created this comment, and then I can pass the comment into the bookmark class to say, here's a new comment for you. But the overloaded versions of add to comments help me not have to do that, right? If I don't really want a reference to the comment, I don't already have a reference to it, and I don't want one, I can just say, I can ask the bookmark class to create the thing for me. And the way I do that is call add to comments and pass a map as an argument. That map will be used to construct a new comment. Then that comment will be associated with the bookmark. It'll be put in that collection, and more will happen, right? If we have the belongs to relationship in place, the reference from the child back to the parent, in this case the reference from the comment back to the bookmark, all that'll be wired up for you inside of this add to comments method, right? And all that's happening because you expressed that has many in your domain class. So it's another example of you've expressed kind of in a declarative way, not an imperative way. You've expressed in a declarative way some things about your object model. You've said that a bookmark has many comments and a comment belongs to the bookmark, and then a bunch of stuff happens that wouldn't be difficult for you to manage on your own, but it's just tedious, more code that you shouldn't have to manage, and GORM is providing all that for you, right? So add to comments and remove to comments are examples of that. Yep. Do you have a question? Nope. Another thing, notice at the end of the chain there, we're calling bookmark.addToComments.addToComments.save. That .save method at the end there is another GORM method, right? You would never write a save method in the bookmark class. GORM adds a save method to the bookmark class, and that save method has all kinds of complexity associated with it, right? It manages persisting the whole graph of objects. Persistence by reachability is imposed here. So if you've got a bookmark that refers to a bookstore, and the bookstore refers to a bookseller, you've got this graph of objects. You save the one object, and persistence by reachability is imposed. There's some things you have to be aware of and deal with respect to if you've got a graph of objects with bidirectional references, for example, you've got to persist the things in the right order. So you can come up with models that involve a little bit of care in terms of what order you persist things. But for the happy path, where you've just got this graph of objects where the references go in one direction, you can just save the one thing, and all the other persistent entities that it refers to will be saved. And you don't have to write any of that code. Yeah? Yeah, so I think the question is, if you've got a persistent entity that has references to things that are not persistent, what happens when you save the persistent entity? Is that the question? Yep, but you don't want to persist them to the database. Right, so we've got a bookmark domain class, and a bookmark has some properties that are persisted in the database, and a bookmark has many comments and all that. And in addition to all of that, a bookmark has a reference to this thing that's there for some purpose, but it's not to be persisted. When you author the bookmark class, where's the simplest version of our bookmark class? When you author the bookmark class here, right? So right here, we might have another property that points to something that's not persistent. By default, all of these properties are persistent. And if there's a property here that I don't want to be persistent, I have to express that. The default is everything is persistent. Hibernate's going to try to map all of these things to the database. So let's say user is the thing that we don't want persisted. So all of this code would look exactly like this. We wouldn't have a has many down here, but this code would look exactly like it does. And in addition to this, I would have static transients equals a list. And inside of that list, I put a list of strings like creator. So the default thing is all of the properties in your persistent entity they're persisted. And if there are properties in your entity that you don't want persisted, you have to express that. Yeah, the question is if you've got a service that maybe returns bookmarks, and there's some part of your application that's going to invoke this service and get back bookmarks, and that part of your application doesn't care about persistence. It's not going to save bookmarks. It just wants to deal with bookmarks. Is there a way to manage that? And for most situations, the way you're going to manage that is you're not going to do anything, right? The thing that calls into the service that says, give me some bookmarks, just won't call save and won't call add to comments and just won't do any GORM stuff with it. What you cannot do is have some bookmarks have a save method and some bookmarks not have a save method. That doesn't make sense. Every instance of the bookmark has these save methods, and it's up to you to orchestrate things in your application in a way that makes sense. So if there's a part of your application that shouldn't be saving bookmarks, don't save bookmarks from that part of your application. If you really do, for some reason, need a class that represents a non-persistable version of the bookmark class, there are a number of things that details we'd have to tease out to figure out what the right thing to do. Kind of maybe the brute force thing to do is have a different class called bookmark 2, or you've got another class with a different name or in a different package, and your service sends a query to the database, retrieves all these bookmarks, and then creates a bunch of these shadow classes and gives that back to the thing. That's almost certainly not the right thing to do, but you could get there using a path like that. Yeah, traits aren't going to help with that. Traits add behaviors to the bookmark class, and those behaviors are going to be there regardless of the It's another way to go, and maybe this is what you were suggesting. This is probably what I think you're talking about. Is you could have a class that represents the non-persistent bookmark, and then have a class that extends that, and that's the persistent thing. That's another way to get there. Well, so he said, or do a read-only thing. You can do that, but that's not. The question was, is there a way to get bookmarks that don't have the save method? The save method's going to be there. You can get the system in a state where the save won't work, but that's really a different thing than. But absolutely, you could do that. You could do things like do all of this inside of a read-only transaction. So nothing can. If something attempts to save updates to this bookmark, it just won't work. All right, let me press on. I've got two more features that I want to quickly look at. Yeah, so enough about the relationship management. Constraints, I'm going to go through this really quickly in the interest of time. When you author a domain class like this, we've got a bookmark class that has a URL, a title, and a date created. That's really bad form. You would never initialize date created. Date created is a special property in GORM, and GORM will automatically initialize that field with whatever time the thing was initially created. So that's just a silly typing mistake there. So, but in any case, we've got a bookmark class with a few properties in it. And in addition to those properties like date created, title, and URL, we've got a constraints property. Static constraints equals closure. And inside of this closure, again, we're using a DSL to describe something. And that something is we're describing what are valid values for all of these properties. So I'm saying that the URL property is not nullable, which turns out that's the default. The title field is not allowed to be blank. It has to be at least 1 character and no more than 255 characters. And date created is not nullable. And there's a lot of there are a lot of things you could express in this constraints block. But we've got a DSL there for describing what are valid values for these properties. So if I create a bookmark and give it a title that is 300 characters long, that's invalid because of the rules that I've expressed here. What it means for the thing to be invalid is if I ever try to save an instance of the bookmark class, like we see here, I've created a bookmark and I've tried to save it. One of the things that happens, so let's say we have this rule that says that the title cannot be longer than 255 characters. So one way I might impose that rule is here, before calling save, I could check b.title and make sure that it's not longer than 255 characters. And if it is longer than 255 characters, go down some error handling path, and if it's not, then call save. But that imperative logic would show up maybe in lots of places in my application. Every place I save a bookmark, I have to have this code that's checking the length of the title. So you don't have to do that, right? Because we took advantage of this constraints block and declaratively expressed this rule, anytime I try to save a bookmark, all of those rules are checked. And if any of them fail, so if the title is longer than 255 characters, the save method is going to fail. It's going to return null. That's the way that the save method tells you that the save was not successful. And then you can interrogate the bookmark object, and there's a way to find out specifically what went wrong. But anytime you call save, those constraints will be imposed, and if any of them fail, then the thing will not be persisted to the database. Right? So that's good. And then finally, I want to take a quick look at some mechanisms for querying the database. And there's some really interesting sort of points to tease out around this. So the first line of code there says def all equals bookmark.list. So there's a static method added to all of your domain classes. You don't have to write it. All of your domain classes get this static list method. And what the list method does is it returns a list, a java.util.list, of all of the bookmarks in the database. So you have to be careful with this. If you work for Barnes & Noble and you've got 4 million bookmarks in your database, you probably don't want to call bookmark.list and retrieve 4 million bookmarks from the database. That'd be a bad idea. So there are ways to constrain the list method. You can tell the list method to only return 100 results. There's pagination stuff, so you can say, give me start at the 200th one and give me 50 after that. So you're going to get 200 through 250. There's a way to do pagination stuff. But for simplicity, what you see here will work. That's going to return a list that includes all the bookmarks that are in the database. Notice there's no mention, there's no SQL here, there's no HQL here, there's no mention of table names and column names. That's a GORM method call that means give me all the bookmarks that are in the data store. That data store might be a relational database. It might be MongoDB. It could be some kind of in-memory map-based store. From looking at this code, I can't tell what my persistence engine is. And if I change my persistence engine, and I'm using Oracle today, and later we migrate to MongoDB, none of this code changes, right? I'm not writing Oracle code here, and I'm not even writing Hibernate code here. I'm writing GORM code, and it's GORM's responsibility to know how to carry that out. So how you retrieve bookmarks from Oracle is radically different than how you retrieve bookmarks from MongoDB, right? The code to do those things are not going to look the same at all if you're doing it directly. But if you're using GORM, GORM manages those differences for you. You call bookmark.list, and GORM knows what to do, right? If your application's configured to use Mongo, then list does one thing. And if your application's configured to use Hibernate, list does another thing. And if you're using Hibernate, list is going to do one thing for MySQL, and it's going to do a different thing for Oracle, right? Even those aren't the same. But even if you go to fundamentally different kinds of stores, all of these GORM methods work. They look the same in your application. You're not writing Mongo code, you're not writing Oracle code, you're writing GORM code, and that's one of the benefits of using a really flexible and powerful ORM tool like GORM. So in addition to lists, there are a number of other ways to query the database. You can call bookmark.findAll by title like is one example of a dynamic finder. So the string that you're passing as an argument there is a like clause. So this is going to return all the bookmarks in the data store that have the word Grails in their title with an uppercase G. And then there's another version of this where it would be find all by title I like, capital I. That's an insensitive like. So this is only going to return bookmarks that have the word Grails with an uppercase G and the rest of it's lowercase. So you've got lots of flexibility. There are just all kinds of different patterns and permutations of dynamic finders. But you get this really expressive way to express what it is you want back from the database. For a long time, so there aren't any examples here of this, but you can put an and or an or in there. So you can say bookmark.findall by title or page number, right? You can, or find all by title and page number. You can put an or an and in there. And for a long time, there was a limitation that you could only do that once. You could say first name and last name, but you couldn't say first name and last name and hometown and age. You couldn't do that. You get one and or one or, but that's it. For a long time, that was a limitation. And again, for a long time, one of the most highly voted feature requests, which I don't think was a great idea, was to support an arbitrary number of those. And there's a JIRA out there for it, and every once in a while someone would comment that says, hey, can we please do this? And you'll find a whole bunch of comments that I left there that says, I really don't think this is a great idea. Kind of the real benefit of dynamic finders is they're really expressive, they're easy to write, they're easy to look at. And if you have a method called find all by title like and page count greater than and publisher inlet, you get this now you're kind of defeating the purpose of a big part of the value of these dynamic finders. You can create these unreadable method names. Finally, we gave in and just supported an arbitrary number of those things. So you can say first name and last name and hometown, and you can make that as long as you like. So if you're really just kind of hell-bent on writing unreadable code, we're not going to prevent you from doing that here, right? You still get to do that. Again, find all by title like is going to generate, if you're using Oracle, that's going to eventually generate some SQL that can be sent to Oracle, and Oracle knows how to do the like stuff. If you're using MongoDB, something fundamentally different is going to happen, but that something fundamentally different is all handled by GORM. Your application code looks exactly the same. All right, and there are other query mechanisms. There's a really flexible and powerful criteria API. In recent versions of Grails, there's a query mechanism known as where queries, where you get to express your criteria in real Groovy code. So instead of calling methods like greater than, you could say age greater than, the greater than symbol, age greater than 4. And so you're expressing your criteria in real Groovy code, and the GORM compiler knows how to parse that and turn that into something that can be dealt with at runtime by your database. Right? Yep. Yeah, the question is, part of the question is, if you use HQL, will it be faster? And the answer is potentially, right? If you can write more efficient HQL code than the ORM tool can generate for you. Actually, the ORM tool is not generating HQL code. It's generating Hibernate criteria stuff. If you're using Hibernate, that means we're done, by the way. So yeah, there are times when folks want to write HQL for performance reasons. Maybe the joins are not happening the way that they want them to happen. You can do that. You can write HQL, and there's a method you can call bookmark.executeQuery, and you pass your HQL string. But now you're not writing GORM code, you're writing Hibernate code. And later, if you pull Hibernate out and plug Mongo in, that's a maintenance point, right? You've got to do something about that. MongoDB is not going to be able to deal with your HQL strings. So if you really do want to write HQL, you can do that. So here's an example of that, bookmark.findall, and there's a bunch of HQL there. You can do that. The reason folks want to do that, there are two primary reasons folks want to do that. Maybe they've already got some fairly sophisticated queries written in HQL in some Java app, and they want to just copy and paste that and drop it into here and go to town. You can do that. Another reason folks occasionally want to do this is they think they can come up with a query that's more efficient than the query that GORM generates, and that happens from time to time. But again, just know that if you do this, now you're writing HQL code and you're bound to Hibernate, right? And if at any point in the future you want to pull that Hibernate out and do something else, you're kind of that's a maintenance point for you. Yes, one more question. Yeah. So the question is, can GORM support multiple data sources? And further, if yes, can it support fundamentally different kinds of data sources? So for example, can I have some domain classes that are mapped to Oracle using Hibernate and some other domain classes that are mapped to MongoDB? So fundamentally different things. And the answer is yes. So there is a plugin called the Data Sources plugin that allows you to configure multiple data sources in your Grails application, and that's how you get there. By default, GORM uses just one data source, and so all your entities are stored in one persistence engine. But if you want to access multiple data sources, the way to get there is with the Data Sources plugin. It solves exactly the kinds of problems or questions that you're asking about. So we're out of time. I'm happy to talk about this stuff all night. I'm not going home until tomorrow. But I don't want to hold anyone up any longer. So thank you all very much for your time. And if you have questions, please let me know.